Thank you, everyone at Microsol, for setting up this webinar today. We've got some really exciting things coming out of the product development team at Autodesk with building performance analysis, and we're really pleased to be able to get this opportunity to share all of this with you. So, everybody, my name is Ian Malloy. I'm the Senior Product Manager for Building Performance Analysis at Autodesk, and what that means is I basically lead the development team that develop tools like energy analysis, lighting analysis, solar analysis in the main authoring tools like Format and Revit. My background, so that you know, is in essentially building science and mechanical engineering, and I've been working in this domain for pretty much the best part of about 20 years now, both developing these tools and also applying them to different building projects at different stages in the life cycle, from early conceptual stage through to building operations and so on. So I'm going to get started straight away here. I've got a lot to cover, so I'm going to jump straight in. I'm just going to give you an overview of what we're going to cover. You know, we've sort of explained this as mainly Revit, what's new in Revit, but Format being kind of a different version of Revit in a different form. I'm also going to cover that as well, because we've got some interesting things in that to share with you as well, and you'll see that this all forms kind of part of a workflow continuity from concept to detail, where you can do energy analysis throughout the entire process. But everything I'm going to cover here today is sort of summarized on this starting slide here, and you know, parking the specific tools aside for a minute, the real areas we're really talking about here is, first of all, is the basic process of architectural modeling, you know, and representation of physical form, you know, from concept through to detail. And we recognize the fact that the way that happens isn't necessarily done specifically for purposes of analysis. And typically in the past, analysis tools and workflows always required, you know, specific custom authoring of an analytical model, you know, particularly for energy analysis. And we've made a number of advances over the last few years, and they're particularly clear to see now in Revit 2016 and in Format, that you can now model as you normally do from concept to detail, including the kind of variety of modeling practice that people have, and accounting for the typical kind of inaccuracies and omissions that are natural in architectural modeling processes, and still create an accurate, reliable energy analytical model automatically, which then allows you to conduct whole building energy simulation, which helps provide you with, you know, indication of performance, and particularly at those early stages when you're making decisions about building form, things like orientation, shading, you know, key architectural decisions that have an impact on building performance. We can provide early indicators to kind of show the impact of those decisions, as well as do early targeting and feasibility on other aspects of building performance and energy use. At the same time as well, we don't expect to provide energy analysis for all needs, and you know, it can get quite advanced, particularly when you get into more detailed design stages and things like lead documentation and so on. And to support those types of workflows, we also provide export in a variety of formats, and namely GBXML, DO2, and Energy Plus. So whether you're an architect looking for, you know, early design stage guidance on energy performance, or whether you're an energy analyst looking to create a more detailed, specific energy analytical model, you know, export the analysis, we've sort of got something for everybody here today. This is pretty much essentially an overview of everything that we've got, so that you can, you know, explore these things yourself. As you said, you know, Format is essentially free to try, and you can get a 30-day trial for free. And Revit, if you've got subscription, you automatically have access to all of these tools. So we really encourage everybody to give these things a go. Give them a try, and you know, if you know, let us know if you need any further assistance. You know, contact us, contact Microsol. We're all here to help you be successful with using these tools. So the place I'm going to start here is really actually I'm going to start with Format, because more than anything, it kind of really represents the direction that we're going with. Because the goal here is to really get people to analysis as quickly as possible, and to provide them with directional feedback with the minimum amount of friction possible, and also with the maximum level of trust and confidence. You know, if you're going to use this information and make decisions, you know, you need to be able to trust that. So, you know, how are we doing that, and how are we sort of mitigating those uncertainties that exist? And that is represented very well in the in Format and what you can see in that state. So I'm going to start with that, and then I'm going to work my way into Revit and work a little bit may not necessarily know, is essentially a conceptual modeler. It's browser-based, but you can also access it through mobile devices, iOS and Android. I'm showing you the browser-based version here today. And it's essentially a very easy-to-use, intuitive, flexible conceptual modeler. And the concept of it is that, you know, from the earliest stages possible when you start to, you know, lay out building massing and so on. In this case here, I've just given the example to sort of explain some of the particular behavior relative to energy analysis. It's a very simple, fluid tool. You know, I can do this sort of drag, push, pull type thing, and it's very flexible, and I can really very quickly represent overall building form. And I can get into more levels of detail. But from an energy analysis perspective, the primary goal is really to inform the sort of the mass form, the overall building shape and impact of surroundings and so on. And that's why I've started with this example here, to essentially show you how it works. The first thing that you can see here is that I have a mass form here in the center, and in that mass form, I've got levels assigned. And the first thing to be aware of is that levels basically dictate what the energy analysis sees as the building and what it sees as surrounding and shading. So in the case of these mass forms, you'll see they don't have levels assigned. And when you look at the energy model at the end of the process, you'll see that they've been translated as shading. So they actually cast shading on the building, whereas this is actually what gets simulated and all the heat transfers inside it and so on. So basically, once I've got my model, all I need is at least one mass form with levels set. And then all I need to do is essentially set a location. So all I need to do is essentially one button away. There's a little button here up in the corner called Energy Analysis. And when I launch that, what you'll see is, unlike other analysis workflows which require you to set a lot of upfront information, this actually kind of walks you through a sort of a progressive set of inputs, and you see the role and value of each one. But the primary thing, and I'm going to use the little startup here to sort of show you, is this primary indicator of energy use and value called the energy cost range. And it's essentially the product of what's essentially the millions of simulations. Now, as you go through the design process, you essentially reduce that, but you start off with a very broad set of settings based on, you know, you haven't set anything yet, and you get to see the impact of each setting as you go through. But basically, the key elements of this you've got an energy cost range, you've got key benchmarks like ASHRAE 90.1 and the Architecture 2030 benchmarks. You've obviously got history as well, so every time you make a change, you'll see the impact on the history, and you can use that to sort of tell a design story or do comparisons. And then we've got the ability to see the actual analytical model itself, because the physical model in Format gets translated automatically into an energy analytical model, including zoning, in order to provide an accurate energy analysis, and we provide you ways to view that. We provide ways to compare different forms with one another. And then also we provide a very clear breakdown of the things that drive building energy performance. We simply call them factors. And a factor could be something like building orientation or lighting efficiency or, you know, roof insulation, those kinds of things. And what allows you to do is essentially start with a very broad range and understand the sensitivity of each thing with a very quick interactive cause and effect feedback. And I'm going to demonstrate that to you now. So basically, to run the analysis, all I need to do is set my building location and then click Analyze. And that's all there is to it. The building location is what pulls down all of the climate data information that we use, and it helps configure the simulations that we run. And then typically, so that you know, depending on your building size, that can take anything from a couple of minutes to maybe a half an hour for a very large model. If you try it out yourself, you'll start to see. But it also depends on server traffic as well. But what we actually do is essentially equivalent to millions of simulations. We don't actually run millions of simulations. We run a large number of them, and then we have a technique of combining the results with a very small loss in accuracy, but it's much more efficient from a processing perspective. And what that provides us with is now a range of energy performance. And here we see a number. In this case, it's dollars per meter squared per year. And this is the current indicator of performance with nothing else set. Remember, all I did is I set location, I clicked Analyze, and what it's telling me here is my mean energy cost is $14.60 a square meter. The maximum might be as high as $23, and the minimum might be as high as $8 or $7 or $8. And the reason is that there's still things that are not set yet, right? And the idea of this is to help you progressively work through the different factors and understand what's important. And there's essentially two ways to use this. One is, and I'll show you this in more detail later in Revit, but one is essentially to not set anything and just use that 14.6 as an indicator of performance. And if I was to go back and, let's say, put in a sloped wall or add a shade or just change the building form in some way, I then see a relative difference between 14.6 and whatever happened next. And what's unique about this is that whereas before that difference was dependent on what all your other settings were, because we're doing these essentially equivalent to millions of simulations, we're essentially able to neutralize or isolate what the value of that one change actually is. And that's really unique in terms of energy analysis. But to give you an example of how that kind of thing can actually be used, we can see here, for example, if we look at building orientation, which is one of the factors, I can see here we've run a range of orientations. And in this case, the default assumption that we make here is that the building has an even distribution of 40% glazing all the way around. Remember, it's very conceptual. And what we can see here is, for example, the highest performing orientation is actually, 0 degrees. We see $14.20, and the worst performing is $14.70. So the orientation has an overall role and impact of about 50 cents a meter squared per year. And what's really interesting about that is that that 50 cents will be seen no matter what any of the other settings are. If I improve the performance of lighting or HVAC or other aspects of the building, the way we run the simulations now, we're able to actually isolate what that value is. So we can see that orientation is not particularly important to this building, but it does play a role. And if it was at all possible, we would be able to take advantage of a better orientation. And what you'll see is we provide a range of building factors like lighting, efficiency, plug loads. They're two of the really big drivers of overall building energy. And then things like wall insulation, roof insulation, glazing. These are all the really common questions that people ask at these kind of early design stages. And the idea is to sort of understand, overall opportunity and impact. And importantly, without having to get bogged down on specificity of things that you simply don't know at a conceptual design stage, but you may just say, for example, I know I'm targeting high performance, therefore I will currently include, pretty much a full range of high performance glazing. I can leave that at that state and then get into the details later when it matters. So I'm going to show you more on the energy cost range later when I get into Revit, but that's, as I said, you can try this in Format today. You'll see the way this works. So one of the things I really wanted to focus on today was really more Revit and how Revit is actually playing a role behind the scenes here, because when you model in Format, you can download that mass form, back here, and you can download the file actually as a .rvt file. If you just go up to here and go to view my files in H360, or even go to export, you can save your file and then open that up in Revit. So if I then switch over to Revit, I can continue my workflow. So basically, just to switch back to the deck to sort of give you a quick summary of that, there's a couple of things I just wanted to point out. So again, the intent of energy analysis in Format 360 is really early targeting and feasibility and giving a clear indicator of performance value. And we use these components, energy cost range, benchmark, factors, and history to help illustrate that. What we mean by mass forms, just because it's a broad word, and what we don't mean by it is we really mean that stage where you're at the true massing level of the building. And remember, the thing I pointed out is that wherever you set levels is what gets processed as the building, and wherever you don't set levels get processed as surroundings. And I'm going to show you that in a minute a little bit more clearly. What we don't handle at this stage in Format, and what you really need to move to Revit for, is what I'm just calling here is design detail. And you'll see here is like, because Format is a very flexible modeler, I can represent in 3D, more complex details of the building. They don't get translated properly, in terms of the nature of the analysis and the way the analysis is configured is not intended for that stage. It's really intended for determining the efficiency of these kinds of decisions. When you get to this level, that's where you need to move to Revit. And the thing I wanted to show you there was, if I go back to the Format model here, and I'm going to show you very quickly, what I've done is you don't see anything, you just click the button, you get the analysis, but behind the scenes, auto-magically, this is what actually gets created. This is actually a GBXML. I'm viewing it in Design Review just so that you can see it. But what you can see here is a thermally zoned, it's on ASHRAE 90.1 guidelines, GBXML of that model. And you'll see here, these are the spaces in blue and green are the actual building, and these here are the shade surfaces, the things that are casting the shade. So that's what's actually happening behind the scenes. You don't need to be worried about that, but if you want to do more advanced things, you can dig in and see that. And you'll see this now in a minute a lot more clearly through the Revit UI, because the Revit UI behind the scenes in the cloud is actually sorry, not the Revit UI, the Revit engine is sort of powering a lot of what's actually going on here. So it's useful to be able to sort of understand what's going on there. Okay, so now to sort of move to Revit. Just get the deck back up. When we talk about what's new in Revit 2016, there's basically a couple of things we've done. First of all, traditionally in the past, we had two different modes of energy analysis. One was using conceptual masses and the other was using building elements. And the situation was use one or the other. We now have a mode that actually uses both. And you don't have to have both in your model. You can have one or the other. But what's really interesting is that by being able to use both and being able to mix them, it really helps span that conceptual and schematic to detailed stage. And there's just a very wide range of uses for those different Revit objects in both design and then also in terms of energy model creation. The other thing to note as well that the old conceptual mass only mode essentially works as it always did. That's the same. But this new mode behaves a little differently. And one of the other things it does now as well is that for the first time, we now have the ability to see Revit elements directly in Revit views and in schedules that represent the energy model. So, and I'm going to show you these in more detail, but this is sort of from here at a high level. What you can see here in Revit under the analytical model categories, you've got spaces, analytical spaces, and analytical surfaces, and then the different types of surfaces. And what you're basically seeing here is actually GBXML. That is the GBXML schema on the right-hand side there. And here I can see a 3D energy model view in Revit. So this allows me to very easily, check my model and understand that, how the energy model creation is behaving and make sure that, that the model is right. Now, the number one question I always get asked here is, well, how much cleaning do I need to do to the model in order to make it right? And definitely in the past, previous GBXML export type workflows required a lot of model preparation. And we've really built this thing entirely from the ground up on the basis of we don't want people to have to rebuild the model. And we accept the fact that architectural models have, small gaps and omissions and overlaps in them as a natural part of them. And we still want to be able to create an energy model from that. So the reality is, in fact, there is no cleaning actually required. There is, however, just a basic requirement that the building needs to be what we call reasonably enclosed. That does not mean perfectly airtight. It just means that, for example, if there was no roof on the building, well, we wouldn't be able to assume that you intended what was underneath that roof to be occupied spaces. So that's what we mean. If there was a small gap somewhere near the roof, that's totally fine. If other errors and omissions and so on are all totally fine. And the purpose of the model view and the workflow that you can follow very quickly actually identifies any omissions from your model. And sometimes they can be fairly serious things that really should be in your architectural model to begin with. So one of the nice things about using this workflow is that it also helps improve the overall quality and completeness of your physical model. So the analytical model is like a good diagnostic as well on the physical model. So in order to understand how this works, I'm just going to give you one more slide on a bit of background on this so that you kind of get some sense of it. So as you move sort of from concept to detail, this is sort of, you don't have to do it in this order, but this kind of gives you some sense of the typical flow. You're kind of using a mix of conceptual massing elements, with or without mass floors, and percentage glazing, and so on. Then I've got architectural building elements, which are the real Revit elements, walls, floors, roofs, curtain panels, ceilings, all of the detail kind of gets layered on. I may have some or any or none of those. It's not a requirement. And then it may or may not have rooms or spaces present. And in terms of spaces, they obviously carry more data for the energy analysis if you want to get to that level of detail. But that really is at that detailed stage. Of course, we want to be able to do analysis earlier in the process. But the point is, no matter what your model is made of, we use under this new mode to create these new elements called analytical spaces and surfaces, which basically spaces are just the discrete volumes of air that gain and lose heat from one another, and surfaces are the path of heat transfer through them. And that's basically the GBXML, and that's what gets passed to Green Building Studio and O2 in the cloud to provide our simulation results. Okay, so that's pretty much the overall kind of mental map that explains how this thing works. And what I'm going to do now is I'm going to jump into Revit to actually show you in a bit more detail. So, and normally again, when people sort of think of Revit, they think of a model like this. They think of a sort of a pretty detailed architectural model with lots of rich, information like curtain walling and so on. And as I mentioned, this feature and this energy model creation algorithm has been designed to be able to create an analytical model from that. And I'm going to finish at this state here. I'm not going to start with that. I want to show you really, because if you only start energy analysis at this stage, reality is you've probably lost a lot of opportunity already. It's still worth doing, and things like LEED and so on will still require you to do that, and you can still export the GBXML. What we really want people to do, and particularly architects at the early design stages, is to start to use these tools earlier throughout the process to inform these big decisions around building form and, window to wall ratio, shading, and things like that. So what I'm actually going to start with is a much simpler model, and I'm going to start with a simpler model as well to help you see the behavior of this feature as well. Okay, so I'm not doing a simple model here purely because this is all that works. I'm doing it so that you can see very clearly what's going on here. Now, in this case here, I have simply a set of conceptual masses like I did in the other format model. Here, I've started to articulate more conceptual masses as spaces, and as before, I've got conceptual masses with mass floors enabled and without. Okay, and I'm going to just show you this behavior now, and I'm going to add to this model so that you can see what happens. But basically, if I go to Analyze, and go to Energy Settings, and go to here, you'll see the mode is contained in here. I'm using this new mode, use conceptual masses and building elements. So basically what I do now, if I just click on Show Energy Model, I've already created it. It'll create a 3D energy model view. And what I've done here is I've actually created two views to separate them out, just so that you can see very clearly what's going on. The top view, if I go to Visibility and Graphics, is the spaces. So look under Analytical Model categories, you'll see Analytical Spaces. And then the bottom view, you'll see these are purely the analytical surfaces, okay? And you'll see each of them having a different type. What this allows me to see is this is essentially what people would talk about as, or think of as, the zoning of the model, the discretization of the overall building volume. And these are the paths of heat transfer. So for example, if I pick here, I'll see there's a space, it's got an area, it's got a volume. Whereas down here, if I pick a surface, you can see it's got the wall, or I've got here, for example, you'll see where these have been translated as shades and so on. But what's nice as well is that we've also got schedules of these things, and then we've also got the schedule of surfaces is also really nice. So for example, if I want to see all exterior walls, I can see them highlighted like that, and all interior floors. So I can very quickly QA my model and check that it's right. Now, the way this is working is very simple. The conceptual masses are simply seen as sort of discrete surfaces, and we automatically detect and compute where discrete analytical spaces or zones, if you're inclined to that word, exist, and then from that create the analytical surfaces or the paths of heat transfer. And in this case, because this model is so simple, you'll see there's more or less a one-to-one translation between where we have spaces and surfaces. It's very straightforward in that regard. You'll also see that by default, there's no glazing in this building yet, so it's applying the overall whole building 40% level. But at this level, that only goes so far. And what I'm going to show you now is the real power of this mixed mode that we have. So what I'm going to start doing now is I'm going to start adding in some actual building elements, and I'm going to do it in a very quick way just to give you a sense of how this thing works. But a very common thing we'll see people do is at a conceptual stage is create a mass and then start to articulate, for example, maybe a curtain wall system or something like that, like here. So if I just create a curtain wall there and maybe there, and then what I'll do is I'll add a wall. Now I'm just using wall by face. It doesn't matter. If you were to model a wall, that would be totally fine as well. And I'm going to show you some of the randomness that it can kind of deal with. I'm just going to put in a wall here like that. So that way I can also put in, for example, start to put in some windows. Now, at this stage, everybody's realizing I'm not an architect, so this is not a pretty picture I'm creating here, but it's just trying to demonstrate the actual behavior. Now, you'll notice the model is not regenerating. That's one of the limitations here. You need to create the model on demand. But another thing I'm going to do, just because I want to show you some of the more advanced things, I'm just going to put a roof up here. For example, if I just pick this one here, create a roof, and I'm also going to extend this roof a little bit. And remember, in real models, these things are maybe not necessarily modeled particularly accurately, or maybe that's a particular design feature. And then also, for example, if I was to go into the building and then start to articulate where I'm actually putting walls and things like that inside the building, like if I put a cut across here, right, just here. Again, I don't need to be particularly precise about this. You'll see where that appears. Now what happens if I create my model again, I need to delete the existing one and just create a new one. You'll see for a model of this size, it only takes, a handful of seconds. It doesn't take long. So here we can see, just continue. And now we can see in here, just one thing to watch, sometimes you need to turn off the masses to see their view, so that restores them. So now we can see actually, so for a start, we can see where the curtain walls actually all have started to appear now as fixed windows in the analytical surfaces. You can see here where we modeled physical windows, we've now got analytical windows. And similarly, where I just randomly drew that wall intersecting the building, I've now got discrete spaces here. So you can see a space here, I can see a space here. And this is where it gets really neat, right? For example, let's say somebody, and I know we're all guilty of this, didn't model this particularly cleverly. And if you just notice what I did there, I just kind of left a little gap at the ceiling there. Well, you'll see now, if I generate this model again, and I'm just doing that to sort of simulate or emulate the kind of inaccuracies that are normal. It doesn't mean that the wall is going to be built that way, but it's just, it would normally be a barrier to doing energy analysis and or be interpreted in a slightly different way. But what we're able to do is we're still able to understand that that's still a discrete space because we understand that gap isn't really a serious gap. Now, if it gets big enough, it becomes a serious gap. And that brings us to the other sort of aspect. There's another setting that we can talk about, resolution. There's more training material we can give you on this to sort of understand it. But basically, the more details you get, the more accurate you get. You just dial up that resolution. And it allows you to account for these kinds of typical kind of modeling inaccuracies and omissions that are in typically in Revit models. So the other thing I just wanted to point out as well is that just because I added this roof with an overhang, you'll see if I zoom in here, you'll see that that's now actually been interpreted as a shade because it's not actually, that part of the roof is not actually bounding any space. It will, however, be casting shading on that glazing. So if I wanted to understand the behavior of that, I could do that. So the bottom line is that with the new visible elements in Revit, and other than not being able to edit them, they behave just like any other Revit element. So I can cut section boxes, I can create views, I can do all kinds of cool stuff to really understand the nature of the energy analytical model. So, you know, there's no more need for a separate sort of third-party, greatly simplified energy analytical model. You can now have it directly in Revit, exported through a variety of formats. I'm going to show you how to get them in a minute. Of course, having this model now, one of the really valuable things to be able to do, obviously, is the simulation itself. And in that respect, that hasn't changed from before. I can simply just click on Run Energy Simulation, and that will send the simulation to Green Building Studio, and the results will get returned here to Results to Compare. And for the moment, at this high level under Results, you'll see that the results are essentially, you know, much the same as they were before. This high-level summary of overall building energy cost, climate data, and so on. But a couple of things I wanted to draw your attention to that we've added recently is that, you know, in particular is the energy cost range. So just in the same way I was showing you the energy cost range in Format, this essentially behaves the same way. Now, the simulations are slightly different because it's assuming that from Revit you've got a little bit more specificity in your model. So therefore, the range of simulations that are run are slightly more tighter, but with a broader array across each. So for example, if I go in here, I can see again, very similar breakdown of things like orientation, lighting efficiency, plug load, and so on. And what I can see here again is get a directional indicator of building performance. So the example I wanted to give you here was to drill into this in a little bit more detail. I'm going to open up two in a browser side by side so you can see them. This is, again, all I have is my Revit model. I've created my energy analytical model, which, just to highlight, at this stage now, if you can do basic architectural modeling using masses and wall floors, whatever combination you have, whatever you have at that early stage as possible, you can create an accurate zoned energy analytical model very easily. It takes about, you know, a couple of hours to learn how this feature really works. And so energy model creation is no longer a problem. All you then need to do is run the energy simulation. If you want to do the more detailed stuff, building type and space types are important. For this early conceptual stage work, you don't even need that because what we do is with the array of things that we run, essentially everything is included because all building type is just a representation of things like different hours of operation, different systems, and so on. And we've essentially simulated more or less everything here. And what I've got here is the result of one simulation of that model where it's showing me $1.66 we're in a square foot now. We've changed units. And again, we've got this array, and we can see here, for example, again, this thing about, let's look at orientation again. We can see the maximum would be 169, the minimum would be 161, which is like an 8-cent difference. Now, again, traditionally, people would get bogged down and say, well, is that 8 cents real? Because, you know, what are your other assumptions, garbage in, garbage out? What's really interesting here, if I just use lighting power density as an example, and say, for example, right now I'm using the entire range of lighting power density. If I was to say, well, let's say this is a very high-performing lighting system, I can see that for orientation, it's still an 8-cent difference. Or even if it was a very low-performing lighting system, you can see it's still an 8-cent difference. So the point is we're able to not only see the role of lighting power density in each of these factors, but also the apples to apples comparison for that one design change. And it could be something as simple as, you know, increasing the height of the building or sloping a wall or, you know, adding more glazing to one elevation or another and so on. You get to see the relative difference. So that's a really, really important aspect to understand about the way the energy cost range works and, you know, how it's really unique in that regard. So we've really essentially made not only the model creation really simple, but then also the actual range of results that we run and how we present those results and help isolate the value of the decisions that you're making or, you know, have just made. So if you continue this sort of workflow along through to more this sort of detailed type model, which again, in this case now we've got things like false ceilings and, you know, more detailed shades and curtain mullions and all the kind of detail that's typical in a model. This is the analytical model that gets created from that. And again, literally all we needed was it needed to be reasonably enclosed. And the only other thing I mentioned was this thing about appropriate resolution. And that's just something that you try it once. And if it doesn't look, you know, right, you can just dial it down. So basically, the more detailed your model, the higher the resolution you need to set that. And it's very quick. You can visually check how quickly that is. And so again, here we can see in this model things like the analytical spaces. I'm just going to turn the architecture off. And we can see, for example, the discrete spaces. And what's really interesting here is that means automatically identify things like ceiling voids, and it will treat them as ceiling voids because we've modeled them that way. You'll see as well, because this model happens to have rooms in the model, you'll see it's actually picked up the room name. And if there were spaces in this model, it will also pick up any of the information like the exact number of people and lights and so on. And that informs what we call the base run in the energy simulation. You'll also see that it's even got details in this like columns and so on. Now, columns don't actually get simulated in energy analysis, but what they do is actually start to occupy, they take up some of the floor area. And floor area is something that's calculated very accurately in this. And one way I can kind of illustrate that is by showing you, for example, all of the surfaces that are slabs on grade. And again, this is I'm just doing this to sort of show you some of the nice ways you can use the views and these model categories to kind of show, you know, what's going on and the nature of your analytical model. So turn the architecture back on, you get to see where they intersect. So you can see, yes, all my interior floor area is right, you know, and it's done that all accurately. We can also do things like, another one I really like showing is where there are shades on the building. So here you can see the surrounding shadings, and these are all shades on the building. So that essentially gives you sort of an overall overview of the new energy model visibility, the combined mode, and the way we're running the simulations on energy cost range. The one thing I just want to repeat again about the combined mode is that you don't have to have both. You can have any mix. It will work with whatever mix you have, and it will determine. It's basically got all the kind of knowledge that an energy modeler normally has when they create an energy model embedded in it, and it just uses the physical objects that you have in the model. So what I'm going to do now is there's a couple of things, you know, that's all great stuff, but I did want to, you know, make you aware of a couple of the limitations that are still there. So we've got all that, right? So one thing to be aware of is that the energy model creation, you know, in terms of the processing time, it does scale with size. So the larger your Revit model and the higher your resolution, the longer it will take. And this thing here is illustrating here how, you know, basically based on, imagine a bounding box around the building. So if you're going to do this for the first time, I would recommend don't do it on your biggest, fattest Revit model for the first time. It's just going to take you longer to learn how this thing actually behaves. Do it a few times with some smaller models, and then you'll understand how, for example, excluding those floor plates which are making the box bigger than it needs to be, and they really don't matter for the energy analysis. It's simply taking longer than it needs to be. And again, if you're starting with a detailed model, we can send you information on basically a 5-step workflow that allows you to create the analytical model out of that very, very quickly. But just be aware of that if you're using a very large, you know, from a volumetric sense model, it will take a little longer. It typically only takes a few seconds to a few minutes. On very large models, it might take, you know, an hour or something like that. There's a couple of other things to remember. Remember, I mentioned there's no regeneration of the model, so you know you need to create it on demand each time. You can't manually edit the EAM elements; they're created by the algorithm, so you know they're visible. You can section box them and things like that, but you can't go in and edit them and scale them and things like that. We currently don't support Revit design options, only the main model. And also we don't support in-place families of arbitrary geometry, right? So if you've got like an in-place family of a lump of bricks or something like that, we currently don't look at that. It's just currently ignored. So that's just something that you need to be aware of. Also remember, you'll notice in some of these models as well that, typically energy modelers have always talked about creating a clean or airtight model. And that's very often been driven by the understanding of the third-party tool requiring a model like that. But in reality, all energy simulations, whether they're DO2, Energy Plus, IES, and so on, they don't actually require, energy simulation does not require a closed shell model. What's important is representation of areas and orientation and so on. Now, one of the byproducts of a more detailed Revit model is you get more detailed analytical model, and we have this concept of what we call pixelated edges. In other words, the model looks a little sketchy in certain right perimeter areas, and it's just because of the detail that's there. They can look a little ugly sometimes, but it's perfectly acceptable from an analytical sense. It doesn't actually impact the analysis to any great degree. Remember, I mentioned that processing time increases with building size and resolution, so we would recommend trying this for the first time. Try it on something small or a test model or something so that you understand basically how it's working, and then work your way up. And, as I said, we've applied this to very large models, but, you just need to know how it behaves. You don't want to lock out Revit for an hour and, be waiting for it to return. There is one limitation in Revit 2016 at the moment around the automatic thermal zoning when you're at that really early conceptual stage, and that the perimeter core zoning follows a basic north-south, east-west division. Now, if anyone here has used Vasari before and missed it, you'll remember it had automatic thermal zoning using ASHRAE guidelines. Now, that's currently embedded in Format. You saw that model I showed you earlier is actually doing the ASHRAE zoning. And one of the things I could share with you now, if it appears for me, there we go, is actually, most of you will know that we're now on a twice-a-year release schedule. If you're on subscription, you'll get what we call OR2, and that feature is actually going to be being added or has been added to Revit 2016 OR2. And I know most people upgrade around that time anyway, so if you're using that, you'll get the new, more advanced automatic thermal zoning, which just adds more accuracy at that very early conceptual stage, and it's just a really nice feature that we've taken from Sorry, we're doing it in a slightly different way, but it essentially effectively does the same thing. And what's interesting, it's not only applied only to the conceptual math element, it works for both. So that's really, really interesting. If anyone's really keen to see that, we can show you more. You can get involved in the beta program and things like that. But that's going to be out in September, so we don't have too long to wait for that. Just a note, again, I get asked a lot about this, about, the accuracy of the energy analytical model. And the thing is, again, to remember that, energy analysis and simulation, the key thing is about comparison and not necessarily about exact quantification. And throughout the design process, it's a bit of a moving target anyway. And you're going from, a concept to detail stage, and ultimately an analytical model is an abstraction, but you're ultimately trying to represent reality. But we've developed a method for kind of computing the accuracy from a geometric perspective. And I was talking earlier about spaces and surfaces. They're the two main elements of measures that you have. And these are the sort of properties. Discretization is just a fancy word for zoning. And then you've got measurable things like area and volume. And if you look across the industry, typical practices, using third-party tools, and an energy modeler won't argue with this, and not that there's anything wrong with it either, because the model is used for comparative purposes. But geometrically, at best, the models may be accurate within plus or minus 10%. And it's because of things like, over or under zoning, and, having an eggshell modeler. You've either got the choice of maintaining floor area or, getting your surfaces wrong, or get your surfaces right, get your floor area or volume wrong. And then also when you've got detailed things like curves and stuff, you've got to simplify them into these planar things. Using the Revit method, because we work directly with whatever's in your model and we add in, we work directly off the physical elements and compute where the zones in the building are, we get much more accurate discretization. We get separate computation of floor area, volume, and surfaces. So each part is discrete and calculated much more accurately. And we don't simplify those things, even though the results would probably be much the same. There's no need to simplify it, so you get a much richer model. Now, granted, that takes a little longer to run on the server, but cloud, infinite computing, all that good stuff, we don't care about that. We just want to, the simplification that's always been done has always been done just as a means of ease of workflow, whereas when there's no need to do that, there's no need. So on average, the Revit model is within about 5%, and that's for a detailed model. It's directly proportional to how accurate or how clean your model is. And what's important, if you do this workflow from an earlier stage, you'll see that actually by the time you get through this process, you're typically more like 1 or 2%, and you're just into the state of noise then. It just doesn't matter anymore. So very, very accurate and also extremely quick. It takes anything from a couple of minutes to maybe a morning for a very detailed model that you're starting energy analysis on for the first time, as opposed to a few weeks for doing something like that. So then just to recap, just to go back and look at everything I could have talked about before I stop for Q&A there. The overall thing is to remember that the main components of energy analysis, whether it's in Format or in Revit, is the first component is architectural modeling. We want you to be free to be able to represent form and shape and the physical representation of the building in as many ways as you're used to doing, from concept to detail, a range of modeling practices, and account for the fact that inaccuracies and omissions will be expected. But for using that, we completely automate the creation of an energy analytical model. So meaning there is no real cleaning, and if you do have any cleaning, you will find that it's highlighting things that are typical omissions in your model. I found things that are valuable to find in your physical model, like missing parapets or whatever it might be, things like that. And then finally, the actual nature of the whole building energy simulation itself, we're changing radically as well in terms of we're no longer running a single simulation. We're now running what essentially is equivalent to millions of simulations with granted a very small cost in terms of overall accuracy, but perfectly acceptable from the perspective of the directional feedback. It's like less than plus or minus 10%, definitely. But the thing is, it allows you to very quickly, as I said, use that as a guide to make decisions about your building form, or then use from a targeting and feasibility perspective to understand, well, what really is the role of glazing? What really is the role of wall properties? So rather than getting bent out of shape about wall properties, we can see very quickly whether they're important or not, and then, continue down through the workflow. There's obviously many more advanced things we can do in here as well around configuration of the simulation. And then, of course, as I mentioned, you can also export GBXML, DO2, and Energy Plus. And in fact, it just occurred to me, this is often a point of confusion. So most people, to export GBXML, they go up here to the File menu, Export GBXML. That's actually what we call like the old room and space-based GBXML export, which still has, it's great if you rebuild the model and have a clean model. And lots of our, customers do that today. But if you're wanting to leverage the architectural model, what you need to do is run a simulation. And when you go to results compare and go to the actual results, you'll see here, it's a little hidden. Go to export, and then from the drop down, you'll see the different file types, GBXML, DO2, Energy Plus. So I'm glad I remembered to show you that. So I think that's my last slide. Oh, just to point out here, obviously, more resources for further information. Our blog is always talking about our latest developments and any training resources and things like that. We've got our help, and then also our forum. We're available for questions anytime, and of course, obviously, Microsol as well can help you with, directing any questions. And if anyone here would like to take further, deeper dives, on a sort of a more one-to-one basis, we can also work with Microsol to set that up. So we'd be happy to do that.